Hi, I'm Fiona, and this is my object-oriented sales data pipeline. The scenario is a retail company receiving daily sales files. I build a repeatable process that takes those raw files, cleans them, and loads them into PostgreSQL for analytics. Something like revenue by day, top products and regions, customer lifetime value, and wage records file validations. The design goal here was classes with single responsibilities instead of one long script. And I'll show you structure and then run it step by step, end to end. So here you can see the whole data trees. And in the source data file, data flow through 5 stages, and each stage is its own file. So the models is the data contract. So you can see here there are 6 data classes, one per stage, and the type of the object tells you where the data is and whether it has been cleaned yet. And the extractor reads the file, the validators applies the rules, the transformers does the money math, and loaders writes the output, the pipeline uh, orchestrates the order, it coordinates the other classes but holds no business logic itself. And finally, the configuration supplies paths and credentials from environment variables, so nothing sensitive is hard-coded. So in the extractor explicitly, here's the abstraction requirement length. The extractor is an abstract-based class. It defines what every extractor must do. So an extract method of each, not how to do it. You can see here we have CVS extractor and the JSON extractor. They implemented completely differently underneath, but the pipeline calls extract and never learns the format file. If we needed another API sources, for example, tomorrow, that's one new subclass and zero changes anywhere else. Since it's enforced, not just documented, so instantiating structure directly would raise the tag forever because the contract isn't satisfied. Okay, so you can see here for the raw data. I design all those 3 input myself, and we had 30 rows, 18 designed to paths and 12 designed to fail. And each failing row breaks exactly one rule, so if a row ever stops working, I can tell immediately which one it was. So start from 1019 was the 12 rows that failed. The brief listed 5 back cases, but I added 7 more across 4 categories. So for referential integrity, we have a no customer and a no product. And in the business rule, we have zero quantity, negative price, discount above one, and negative discount. And for format and tab, I created USL date, amazing field, and a quantity that says ABC. And there are 3 more. I think is also important. So I created date called 2026 February 30th. The format is valid, but the February would never have 30s. And I created a duplicate order ID, which would double count the revenue, and an order date in 2027 in a January 2026 file. So almost certainly a data entry error. Okay, now we can move to the validation part. All the validation rules here live in this one class because rules change more often than anything else in the pipeline. So keeping them isolated means nothing else has to change when the rule does. So 2 things I'd point out. First one is that a role collects all of its failure reasons, not just the first. So whoever fixes the data sees every problem in one pass instead of fixing one thing and resubmitting. And also the validation and tab conversion here are the same step. So for example, successfully parsing 3 into an integer is the proof that it is an integer itself. That also means the order matters. I I would parse before I compare. Like for example here, otherwise checking whether the ABC is greater than 0 would crash instead of producing a clean rejection. Okay, before anything goes into the database, I want to be able to check it. So the pipeline has a dry run mode. It runs the extract, validate, and transform completely, but read nothing to PostgreSQL at all. So you can see here, 30 rows read, 80 invalid, 12 rejected, and the calculated totals all visible before a single row is loaded. And this is how I know the output is correct before I actually run it. The pipeline checks the 5 invariants on every single run. We have a record conservation, so the valid plus rejected has to equal the total rows rate. If those doesn't match, records are being silently dropped somewhere, which is one of the nastiest bugs a pipeline can have because nothing actually errors. And we have the money identity. The gross minus discount must equal the net. Exactly. So that would catch any floating point, drift, and inconsistent rounding. Plus, no duplicate keys and no fact row pointing at a customer or product that doesn't exist. The important thing is this holds for any data set, not just this one. And the main Python file access with a non-zero code if any of them fail. So on a scheduler, a failure gets caught automatically instead of sitting unnoticed in a log. Okay, so the pipeline also rests two files, and it rests them even in the dry run mode. So the first one is the preview. We have all 18 fact records with the calculated month, so I can check them row by row in Excel if I want. And it also print out the rejected file, so every file throws with its reasons and critically the source line number. So a rejected record traces straight back to the exact line in the original CSV. That lineage comes from the data model and is what makes the result auditable rather than just plausible. Now, the real load. I would call the main file. So you can see the same run, but it actually rests to the PostgreSQL. You can see the row counts here per table at the bottom. And this is for environmental separation. Since the task and production are two separate schemas and selected by one setting in the environmental file, and the code is completely identical. Since my normal workflow is load to task, check it, and then promote to prod, so unverified data never reaches production in the first place. Okay, moving to the schema part. I have a little schema graph there. The database design is a star schema. We have fact cells sits in the middle and holds the measurable event, and the dim customers and dimension products describe the business entities, and the staging cells is the landing zone for validated roles, and the rejected cells is the audit role. I did consider the alternatives. I didn't snowflake it because the dimensions are shallow. Region and category are single attributes, not hierarchies worth splitting into more tables. So snowflaking would add joins and buy me nothing. And I didn't fully normalize it because this is a read-heavy analytics workflow, not a transactional system. So a little controlled redundancy in the dimensions by simpler and faster queries. And that's the right trade here. So you can see the actual schema SQL file here. Two details I want to point out as well. So the money columns are using the numeric, never float. That matches the decimal type I use in Python, so precision is preserved end to end. And this check constraints deliberately repeat rows the Python validator already enforces. That's defense in depth. If data ever wrapped through some other path that bypass my path plan, the database is still the last line of defense. Okay, now I can move to the actual business question. So with this analytic SQL file, we can answer the actual business question. I will open my dbeaver here. So this is the analytic SQL file. And how much revenue did we make each day? We can see for each date, how many orders, how much the gross sales and net sales. And we can also check that which product, the wireless mouse, has the most revenue. And the region, the West has the highest sales with 549.75, followed by East, South, and North. And we can also check that which customer has the highest lifetime value. So if we see 05 Masuva with the highest lifetime value, 482.45. And the rejected record with the reason for each one and the source line number. So anything that failed can be traced, corrected, and replayed. And we also have those rejection reasons grouped, so you can see which roasters fires most often. Okay, so last thing before we want to rerun the whole pipeline to check that rerunning the whole data pipeline doesn't duplicate anything. You can see here the row count stay at 18 because the loads use on conflict do update. Rerunning is completely normal in data engineering, whether you're backfilling or fixing a bug, so loads have to be safe to repeat. Okay, to summarize the design thinking, first, we use decimal instead of float because a few cents of derivative rows, thousands of rows because a reconciliation problem, and it carried through into numeric columns in the schema. And the lineage on every record because traceability is what makes result auditable. The rules isolated in the validator because they change most often, and a transformer that knows nothing about its destination. So the warehouse could change without touching business logic. And never load the unverified data into production. Hence, we have the dry run, the invariant check, and the separate tests and pros schemas. And each stage is one class with one responsibility. So any stage can be replaced without disturbing the others. And that will be all for the whole data pipeline. Thank you, folks. Thank you, folks.